If we're going to write something in function notation, all we got to do is get y by itself. So we've been writing things as like y equals mx plus b. Same kind of stuff. We're going to write it as y equals all the stuff, and then we're going to change that y to f of x. This f parentheses x is referred to as f of x, and we'll talk about more what that means here in just a second. But this first one, got to get y by itself, so I'm going to add 4 to both sides. That would leave me with y equals 3x plus 10. So that's step one, get y by itself, and then I'm going to change that y to f of x equals 3x plus 10. It's really just a fancy way. Uh, Math people write y equals mx plus b. We're going to use that f of x to kind of show different things with functions. This next one, got to get y by itself, so I'm going to bring this 4x over here. That would leave me with 2y equals 14x minus 4. And then I just want y by itself, so I'm going to divide everything by 2. That by 2, that by 2, and that by 2. That would leave me with y equals 7x minus 2. And I'm going to change that y to f of x. So I'll have f of x equals 7x minus 2 would be my final answer in function notation. So I have all these functions, f of x, g of x, h of x, j of x, k of x on the left side. And I'm going to, look at the right side and I need to evaluate g of 10. Normally goes right here where this 10 is, and x. So I've got g of x is equal to x squared plus 4. So if I have g of 10, I'm just going to replace that x with a 10. Wherever I see an x in that function, I'm going to plug in a 10. And then I'm just going to punch in my calculator. So 10 squared plus 4 gives you 104. And if I have f of 3, I'm going to say f of x equals 3x plus 1. And wherever I see an x, I'm going to plug in a 3. So f of 3 is equal to 3 times 3 plus 1. It's important to use those parentheses, not necessarily on these, but when you have a negative number you multiply, just make sure you use the parentheses. I think that'll give you 10. So f of 3 equals 10. Or when x equals 3, y equals 10. J of 4. So I'm going to take the j function over there. J of 4. And wherever I see an x right here, I'm going to punch in a 4. So I got 1/2. There's the x minus 3. And I'd punch that in my calculator. I think that would give you -1. So j of 4 is -1. Next one, if you want to push pause, try these. Be a good idea. Punch them in, see what you can get. H of -4. So I'm going to use the h function. I'll have h of -4 equals -2 times -4 minus 7. So h of -4 equals, I think, 1. So whenever x equals -4, that means y equals 1. K of -1. K of -1. Just going to plug it in down there to the k function right there. 30 over -1 plus 4. So k of -1 equals, I punch that all in my calculator, and I think it gives you 10. So when x equals -1, y equals 10. G of -8. G of -8. Same thing, going to plug it in, -8 squared plus 4. So g of -8 equals, I think, 68. These are a little bit different. I got variables or letters over there that I have to punch in. So, normally this would say f of x, but I want f of m. So I'm going to take this, and just like I would if m were a number, 5, 6, 10, 30, 50,000, I'm just going to punch in m. So f of m equals 3m plus 1. And that's it. No simplifying from there. K of D. So I'm going to take the K function. K of D would be 30 over D plus 4. That's it. G of 2x. So I got G of 2x is going to be 2x squared plus 4. And I could leave it like that, but there is some pretty easy simplifying I could do. 2x squared, that's like, say, 2x times 2x. You multiply those numbers in front and add your exponents on those. So that would be 4x squared plus 4. So that's probably what you're looking at as a final answer. Function notation. So just like we had said, normally there's an x right there. So f of x would give me a y value. So that's like saying y equals -5. So when x equals -3, or the point -3, y equals -5. So the point -3, -5 would be on my graph right there. The next one, f of -2, normally an x goes right there. These are x, y points right here. So -2, -3. This one would be 0, 1. Let's plot those -2, -3, and 0, 1 would be right there. 1, 3 would be up there. And 3, 7 would be right there. And 4, 9 would be right there. And hopefully you got a ruler or something and you could draw a really straight line that goes through those. Mine's going to be pitiful. Maybe not too bad. And if we're writing this, this says f of x, but if I were to write this in y equals mx plus b format, y and f of x mean the same thing. So I got f of x equals, my y-intercept is 1, so I'm just going to say 1 over here for b, and then my slope, it looks like I'm going up 1, 2, and over 1, up 1, 2, over 1, up 1, 2, over 1, so 2x plus 1 would be my function. Looking at a table, if I have f of 5, this is normally, f of x. So I want when x equals 5, what do I get? So I'm going to look over here at the x's. When x equals 5, my y value is 3. When x equals 3, so when x equals 3, y is 5. When x equals 4, my y value is 2. On the right side, I'm looking for an x. So normally there's an x right there. I'm looking for an x when my y value is 1. So my y value is 1. That means my x value is 2. F of 2 gives you 1. So when x equals 2, the y value is 1. I'm looking for an x value that gives me 2. So there's a give you 2. There's my x value that gives me 2. I'm looking for an x value that gives me 4. Right there. F of 1. If you want to push pause, try this one. It's probably a good idea. F of 8, so when x equals 8, that's 10. When x equals 7, that's 9. When x equals 10, that is 7. On the right side, I'm looking for an x that gives me 6. This gives me 6. That would be f of 9. I'm looking for an x that gives me 7. That would be 10. I'm looking for an x that gives me 8. That would be 6. So once again, kind of looking at a graph instead of table, I've got, when x equals -6, so I'm going to go on the x-axis right here. Here's the x-axis at -6 right there. That would be point B. So when x equals -6, my y value right there looks like it would be 2. When x equals 2 right here, looks like it's point E up there, my y value would be 4. When x equals 7, it's right there, looks like it's point C, my y value would be 6. When x equals -1, it's right there, it looks like my y value would be 3. And working backwards, when f of x, normally we would read that as y equals 4. So now instead of looking on the x-axis, I'm looking on the y-axis. So when f of x equals 4, or when y equals 4 right there, looks like it's point E over here, x would equal 5. X equals 5 when f of x equals 4. The next one, when y equals negative 5, when y equals negative 5, that's down here. Y equals negative 5 is point C. X is going to be 3. When y equals negative 2, that's right here. Looks like it's point F. X equals negative 3. And when y equals 3, man, I erased some of those dots. Where did they go? I hope it was point, man, I don't know where it is. Maybe it was point A. Wherever that dot was right there. I don't know which one it was. I'm going to pretend it was point A right there. And that's going to be 4. And now we're just looking at graphs. It's the same thing, except, instead of there being dots all over the graph, I have dots, but it's just infinitely many dots. There's one right there, 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 right there. All of those are dots on my graph. So when x equals 2, that's right there. That would be that point on the graph. That would be negative 2. When x equals negative 5, that would be right there on my graph. That would be 5. When x equals 4, that would be 0. When x equals 6, that would be 2. And working backwards, when y equals 4, so when y equals 4 right there, that'd be that point. That would be negative 4. And when x, we're looking for an x, when y equals 2, that would be 0. When y equals negative 1, that would be 6. And when y equals 0, that would be 4.